Hello everyone, hope all of you are well. Today we will learn parallel data transfer, parallel printer interface, keyboard interface, display interface, input-output system and designing of input-output system. Data is transferred in the form of bits between two or more digital devices. There are two methods used to transmit data between digital devices that are serial transmission and parallel transmission. Serial data transmission sends data bits one after another over a single channel. Parallel data transmission sends multiple data bits at the same time over multiple channels. Serial data transmission occurs between two computers or from a computer to an external device located far away. On the other hand, parallel data transmission can take place within a computer system through a computer bus or to an external device that is located nearby. Parallel communication is always have been widely used within integrated circuits, in peripheral buses, and in memory devices such as RAM. Examples uh, can include connection between a computer and a printer. Generally, most printers are within 6 meters or 20 feet of the transmitting computer, and the slight cost of extra wires is offset by the added space gained through parallel transmission of data. Advantage of parallel transmission: it is the speedy way of transmitting data as multiple bits are transferred simultaneously with a single clock pulse. Disadvantage of parallel transmission is it is costly method of data transmission as it requires more than one lines to transmit the data bits at the same time. The parallel The parallel port interface on the computer is one of the most flexible interfaces for connecting the PC to a wide range of devices. The interface was originally intended purely for connection to printers, but due to the simple nature of the device of the digital control lines, it has been found in many other uses. Its simplicity relies on the fact that the data to and from the port forms an 8-bit binary on-off pattern. This pattern is accessible and measurable directly on the corresponding connection pins on the 25-way D-type connector on the PC. During standard printer operation, the way in which data is transmitted over parallel port varies, but a general description follows. To send a byte of data, the software outputs the byte to the data lines, then pulses the stored output. The device on the other end, normally a printer, then asserts its busy line. The PC waits for the busy mode to go away before sending the next byte. In other implementations, the acknowledgement line is used for the printer to signal the PC that it has received the previous data. The other control lines are used for various purposes. The most common standard for parallel printer interfaces from the 1970 to the early 2000 was the Centronics interface, originally defined by printer manufacturer Centronics and widely employed throughout the industry. A keyboard interface allows user to provide keystroke input to programs even if the native technology does not contain a keyboard. For example, a touchscreen personal digital assistant have a keyboard interface built into its operating system as well as a connector for external keyboards. Three keyboard interfaces are currently very common in use. First one is AT keyboard interface. AT keyboard interface was introduced in 1984 and is still used by the few AT and BAT motherboards still being produced. AT keyboards use Type DIN connector. The PC side, the AT keyboard uses an Intel 8042 or equivalent interface chip. This is assigned IRQ1 and input-output base address 0060. PS2 keyboard interface. The PS2 keyboard interface was introduced with the IBM PS2 series in 1986 and is now used by all type of ATX and ATX variant motherboards. PS2 keyboards use the 16 mini DIN connector. On the other side, the PS2 keyboards use the same Intel 8042 equivalent interface chip at the AT keyboard, which is also assigned hierarchy 1 and input-output base address 0060. Last one is USB keyboard interface. Some keyboards can be connected to a USB port. Most USB capable keyboards also provide a standard PS2 connector via either a split cable with both USB and PS2 connectors or a separate adapter that converts the USB connector to PS2. To use a USB keyboard, the PC's basic input-output system must support the USB keyboards and must run an operating system that supports USB. Their support basic input-output system support is needed so that the keyboard can be used before the operating system loads to do such things as changing setup parameters or choosing options from a boot menu. Operating system support is required for the keyboard to be accessible after the system boots. As the type anything using keyboard, the processor in the keyboard analyzes the key matrix and determines what character to send to the computer. It maintains these characters in its memory buffer and then sends the data. Many keyboards connect to the computer through a cable with a PS2 or USB connection. All display interfaces continuously fetch the frame buffer data, that is the buffer in the system memory that contains the image to be displayed. DisplayPort is a next generation video display interface that uses from 1 to 4 lanes of video data. Each lane is a single wire with a clock embedded in the serialized data. Now describing some DisplayPort. First, S-Video. S-Video was a high-quality analog signal and was the standard for video and TV until the arrival of HD and HDMI. Then Composite. Composite or RCA has the lowest quality signal, but it is okay for video transfer. Another type of video cable such as RCA sockets with much higher signal quality is component video connection, which has separate RGB cables. They are not widely used. Now, BGA. BGA is still popular even though it has been around since 1987. It uses analog signals. The plugs and sockets are blue and have 15 pins. Cables can be up to 15 meters in length, although 50-meter high quality cables also exist. Then DVI. DVI became popular in about 2005 in a digital interface. It is still widely used but might be replaced eventually by DisplayPort. The provided digital signal has 24 pins. The extra 4 pins sometimes included are for some analog signals. The interface is designed to transmit uncomposed digital video and can be configured to support multiple modes such as DVI-D, DVI-A or DVI-I. It is possible to buy DVI to HDMI converter cables. Now, HDMI, high definition multimedia interface. This is a totally digital connection which includes high quality audio. It reassembles a USB port but with tapered corners. HDMI supports two-way communication between the video source, enabling new functionalities such as automatic configuration and one-touch play. The maximum cable length is 10 meters without the use of a repeater. Although triple shielded 50-meter cables are also available, HDMI is fully backward compatible with DVI compliant devices. However, some PCs with DVI will only support monitors but not television formats. Last one is DisplayPort. It looks very similar to HDMI but has only one corner left. It has 20 teeny pins around a central plastic strip that is like USB. It is becoming more widely used in computer monitors. The DisplayPort signal is not natively compatible with DVI or HDMI. However, dual mode DisplayPorts will transmit a single link DVI or HDMI signal across the interface and use a passive adapter that selects the desired signal. On the other hand, VGA and dual link DVI require active adapters and do not require dual mode display ports. Dual link DVI adapters rely on an external power. In computing, input output or I/O is the communication between an information processing system such as a computer and the outside world, possibly a human or another information processing system. I/O interfaces are the mediums in which data are sent from internal logic to external sources and from which data are received from external sources. The interface signals can be unidirectional or bidirectional, single-ended or differential, and could follow one of the different input-output standards. Input-output interface also provides a method for transferring information between internal storage and external input-output devices. Peripherals connected to a computer need special communication links for interfacing them with a central processing unit. Typically, a CPU communicates with input-output devices via a bus. The interface must have the necessary logic to interpret the device address generated by the processor. Handshaking should be implemented by the interface using appropriate commands like busy, ready, and wait, and the processor can communicate with an input-output device through the interface. The major issues can arise that may arise here are peripherals are electromechanical and electromagnetic device, and CPU and memory are electronic device. Therefore, a conversion of signal values may be needed. Secondly, the data transfer rate of peripherals is usually slower than the transfer rate of CPU, and consequently, a synchronization mechanism may be needed. Thirdly, data codes and formats in the peripherals differ from the word data format in the CPU and memory. And lastly, the operating modes of peripherals are different from each other and must be controlled so as not to disturb the operation of other peripherals connected to the CPU. To resolve these differences, computer systems include special hardware components between the CPU and peripherals to supervise and synchronize all input and output transfers. Input-output devices are the pieces of hardware used by a human or other system to communicate with a computer. Mouse, keyboard, etc. Take physical movements that the human user outputs and convert them into input signals that a computer can understand. The output of these devices is the computer's input. One of the important jobs of an operating system is to manage various input-output devices including mouse, keyboard, touchpad, disk drives, display adapters, USB devices, bitmap, screen, LED, analog to digital converter, on-off switch, network connection, audio input-output printers, etc. An input-output system is required to take an application's input-output request and send it to the physical device. Then take whatever response comes back from the device and send it to the application. Input-output devices can be divided into two categories. First one is block devices. A block device is one of which the driver communicates by sending entire blocks of data. For example, hard disk, USB cameras, disk on key, etc. Then, character device. A character device is one with which the driver communicates by sending and receiving the single characters, that is byte or octets. For example, serial port, parallel port, sound cards, etc. In designing an input-output system, the steps need to follow are analyzing performance, cost, capacity, and capacity using various input-output connection schemes and different numbers of input-output devices of each type. First, firstly, we need to list the types of input-output devices and buses and also their codes. Then, list the physical requirements of each device. These include volume, power, connector, bus slots, etc. This won't be a problem for paper examples, but it certainly will be for real systems. Firstly, we need to figure out the CPU resource demands for each input-output device. That may be clock cycle clock cycle to initiate, support the operation of, and complete request. Clock stalls from input output access to memory, clock cycles to recover from an input output activity such as cache flush. Then list memory and input output buses resource demands for each device. It may be bandwidth of main memory, and the input output bus can offer to be a bottleneck, particularly when many devices are connected to a single bus. Then compute performance of various configurations of devices, buses, etc. This can really be done by building the system and measuring it. This is not feasible. The next best thing is detailed simulation. Questioning model can be used to get a rough estimate of performance. Today's lecture is complete. Thank you everyone.